All right, this is a Supernode example. This is the same example we did in class, and I've got a little circuit drawn here. Now, we've got a 6 milliamp source, current source. We show an I1, which is the current through the 6K ohm resistor. We show a current I2, which is the current through the 12K ohm resistor. Both of those currents in the downward direction. And on the other side of this thing, we've got a 4 milliamp current in the downward direction, current source. And there's that 6 volt voltage source up on top. So what we want to do here is we want to find I1 and find I2. So we've got a little bit of a dilemma here to solve this thing. So I'm going to write something down. I'm going to just say this. I'm going to say to solve. Let's write it out. We need to recall that n minus 1 linearly dependent equations are required to determine the n minus 1 non-reference node voltages. It should be an n, node voltages, in an n node circuit. Okay, this particular circuit has 3 nodes. Okay, I'm going to throw a reference in here. I'm going to label that as a ground. Okay, and we'll make it this bottom node here. So we've got 3 nodes. Actually, I'll make these in green. Got a node here. Okay, I'm going to call this node 1. And I'm going to call this node 2. All right, so we can define a couple node voltages. We can define V1 and V2. Okay, so the network, let's write a couple other things down here. This network has 3 nodes, and that's including the reference ground node. All that means is when we're measuring voltage, calculating voltage, we're calculating or measuring it with reference to that to 0 volts or ground. So the objective here, we look at it, find V1, find V2. Okay, if we know V1, we know V2, we know the value. We know V1 is dropped across the 6K ohm resistor. We can just use Ohm's law. V1 divided by 6K ohms is equal to the current I1, and V2, whatever that is the current through I2, through the or current through the 12K ohm resistor. That's what we're calling I2. So if we look at V1 and V2, well, before we do that, I'm going to draw a blob. I've drawn it in red here. This is one of these things we're calling blobs. Okay, that's a supernode. Okay, and we can use the supernode in our analysis to find V1 and V2. So if we look at V1 and V2, bear with me here, switch back to blue. So let's just say this. Let's say looking at V1 and V2, okay, the difference is constrained by the voltage source. Okay, that's that 6 volt voltage source. So we can say V1 minus V2 is equal to 6 volts. Okay, that's our first equation. We said we needed 2 equations to solve. We have 2 unknowns, V1 and V2. So that is actually our first equation, and that is called a constraint equation. And it's represented basically as our supernode. Writing small here. What is circled in red? In our circuit. Okay. I'm going to add another page. I'm going to flip the orientation here. I don't know why it's doing this. Okay. All right. So, and that's our first equation. So this becomes one of the 2 equations. We need to solve the problem. Okay, so we got one equation. We got to find a second one now. Let's just say with this, we now need a second equation. To get the second equation, okay, we can apply Kirchhoff's current law to the supernode area, the blob area, the constraint area, whatever we want to call it here. So let's just say to the red circled area, we are calling supernode. Okay, and if we go to KCL, Kirchhoff's current law, again, sum of all currents going in and out of the out of a node is 0. Okay, so KCL at the supernode, and remember that supernode is the whole blob, everything that's circled in red. We got 6 milliamps going in, so we'll call that positive. We got I1 coming out, that's negative. We got I2 coming out, that's negative. And the way we've got the 4 milliamp independent source drawn, it's coming out of that node, or out of that supernode. So that's going to be minus 4 milliamps. It's equal to 0. Okay? Now we can make a substitution. We know I1 is V1 over that 6K ohm resistor. I2 is V2, we said this earlier, over the 12K ohm resistor. Make a substitution. Combine. We got 6 milliamps minus 4 milliamps. That's a plus 2 milliamps. Minus I1, which is V1 over 6K ohms. Minus I2, which is V2 over 12K ohms. That's going to be equal to 0. Okay, and you can figure out how you want to solve this thing. This is your second equation now. Now we've got 2 equations, 2 unknowns. We've got 2 equations. Our 2 unknowns are V1 and V2. We can solve them simultaneously. I'll let you work on that. But when you do that, solving, let's just say, use the method of your choice. You should get V1 is a plus 10 volts. Again, that's with reference to the ground we've drawn there, our reference node. And V2 is equal to 4 volts. Okay, so we found our 2 unknowns here. Now, once we know these, we just use Ohm's law. We can say I1, we said, was what? V1 over 6K ohms. So that's 10 volts. 6K ohms. That's 1.66 milliamps. I2 is V2 over R2. So, or I'm sorry, V2 over 12K ohms. So 4 volts over 12K ohms is 0.33 milliamps. So there's our two answers, I1 and I2. And it's really that simple. So this is, again, another method you can use to solve for things you may not, they may not be obvious.